Hello, everyone. Welcome to the Karmada Community meeting. Today is May 16th, 2023, Tuesday. The meeting is being recorded and the video will be uploaded to YouTube. I'm one of the maintainers of the project, and I'm very excited to attend this meeting because it's our first meeting where we can talk to English speakers. Since last year, I have been asking for comments about the meeting time on GitHub, but it's really difficult to choose a time that suits everybody. Now we choose this time that we hope it is suitable for friends from the United States and the Europe. Even though it's a little bit challenging for me, note that the meeting is a regular bi-weekly meeting on Tuesday, and you can subscribe to the calendar to get the notifications. And please feel free to add an agenda to the meeting if you want to discuss anything during the meeting. By joining the mailing list, you will be able to edit the meeting notes. Okay, today we have an agenda of a general introduction to the Karmada project and the community. But before that, I'd like to invite Kevin to say something. Kevin is the founder of the project and as well as one of the maintainers. Hello, Kevin.
Hello. Am I clear? All right. Thank you everyone for joining the community meeting. It's really excited to have you guys here. I just want to briefly introduce the Karmada project. So actually, you might know that this project was actually the federation in the Kubernetes upstream. We started in back to 2015, and there was a lot of discussion and a lot of effort in the upstream multi-cluster SIG, and we actually experienced two versions of the actually the prototyping and the implementation, and actually got a lot of adopter. So starting with the new project name, actually we are kind of extending the project scope to not just limiting on the API and also the application management, but also taking the cluster lifecycle and also the scheduling into consideration. And also we are expecting a deeper integration with the other projects, especially those in CNCF and also outside CNCF. And for you may also know that this time we are kind of starting with providing the Kubernetes API conformant functionality to better help users to kind of migrate from single cluster to multi-cluster. And I'm sure you have a lot of things would like to discuss. And before we going into that, I would like to encourage you guys to just briefly introduce yourself. Okay. Is anyone would like to be the first, or we can just go through the order?
Yeah, sure, I can go first.
Mm-hmm.
Hi everyone, my name is Rakshit Gondwal. I'm a second year student from India. I am a GSOC mentee for CNCF under the project captain, and I'm also a team member for VMake Devs. And I'm looking forward to contribute to Karmada in the future. Thank you.
Thank you.
I can go next. I'm Mike Yang. I'm a Red Hat software developer. I'm also one of the maintainers for the Kubernetes 6 work API, and I work with Honkai on that API project for a few items. So very nice to be here, and thank you for hosting this meeting.
So, hello, my name is Abhijit Singh. I am a Java developer in a startup in India. Currently, I want to contribute in CNCF, and I'm looking as a beginner in open source. I'm looking for an opportunity. I have knowledge about Go Kubernetes, but I have not contributed till now. So, looking forward to that.
I can go next. Hi, everyone. My name is Michael Chen. I'm a software developer at Bloomberg in New York City. I work on a Kubernetes-based deployment platform, so interested to find out more about Karmada. And thank you again for finding the time to host this meeting.
Yes, I can go next. I'm also in Bloomberg. We're a sister team to Microchan's team. We manage the Argo workflow as a platform to internal users. And we work closely with other team that manage multi-clusters for us to host the different platforms. Yep. So we're interested in Karmada. See, it has a great potential to help us manage all those platforms. Thanks.
Ying, Ying,
Yeah,
would you like to?
sure. I would like to go next. Hello, I'm Ying Zhang. I'm a software engineer at Zendesk located in San Francisco, and our company is currently adapting Karmada to managing our Kubernetes clusters. At the moment, we have like 20-ish Kubernetes cluster hosted on AWS, and we would like to use Karmada to to help managing the clusters, because in the future we are gonna build more clusters in a partition. And also another use case is we are gonna use Karmada to help us do the blue-green migration. Currently, we build our Kubernetes cluster using our own customized tools instead of like EKS, but in the future we would like to migrate all the cluster to be the EKS. Yeah, I really appreciate Karmada team. They're super helpful and quick response. And just yesterday we had a meeting with Karmada team to discuss our back issues. And we're going to continue to contribute to Karmada. Thanks.
Thanks. Anyone want to introduce yourself? Okay, I
can go next.
Okay, sure, go ahead.
Can you hear me well? So I'm José. I'm a postdoc researcher at Ghent University in Belgium, and I've been contributing to several communities. One of them, for instance, is the SIG scheduling community. And now I'm also working on multi-cloud orchestration topics. And thank you for organizing this meeting, because I'm looking at Karmada right now, and I would like to know how I can be more involved in the future. So thank you for organizing the meeting.
Okay, thanks. Okay, I will take silence as no. Okay, now Jiang Wei, you can go ahead now. Let's yeah, you
okay.
you can just share your screen.
Okay, get it. Enter screen. Can you screen?
No.
Entire screen share. Oh, wait. Okay, I'm sorry, it's a privilege about the MacBook. It's and now.
No.
Share. Okay. Let me just for a moment, maybe 30 seconds to restart the Chrome. Entire screen.
Yeah, I
So
see someone.
now you can see the screen, right?
Yes, I can see myself. You are sharing the Zoom window.
Okay, now I see your screen. So hello everyone, can you see the PPT, the PowerPoint?
No. You are sharing the.
Yes. It's coming. Now you moved it to the browser again.
Wait. 怎么回事呀？
I guess yeah, fine. It's okay. Okay now.
We can see your Zoom windows. So if you move the presentation window to the Zoom
Hello?
window. Okay.
Can you hear?
Yeah, yes.
Yes, we can hear you.
Okay.
What? Hi, Hongcai, can you check the message? Can you hear me? Looks like microphone not work.
Yes, I can hear you.
Okay. Okay, let's just start. And about a briefly introduction about Karmada. So the first we should know, why Karmada comes out. So from the Flexray report of 2023, there's many companies they trying to use multi-cloud and multi-clusters. Like here,
Sorry.
where there is maybe near to 87% about multi-cloud. There is many companies. So, but multi-cloud is nice. It has high availability, have bigger resource threshold. But there are some problems. So there is some problem like too many clusters. You should manage them separately, and also the API may be different. You should manage them differently. So second is workload fragmentation. Like the clusters may different, so you should differentiate cluster configurations. Also, this like you deploy service in multi-cluster, so the multi-cluster service discovery is required. Also, you need to sync APPs between clusters. Like when failover, you need to mitigate the workloads. Third is the boundary of clusters. You should schedule the resources between across clusters, and also you need to ensure application availability across clusters, and also that horizontal auto scaling across clusters. And also, if you like, there is many multi-cluster products, but it's not general API, so we should avoid vendor lock-in. So Karmada try to solve these problems. And also here we give an overview about Karmada. So Karmada is out-of-box solution. It allows you to easily connect to existing clusters, quickly enable multi-cluster capabilities, and efficiently manage and deploy service with high availability.
Yeah.
Here, Karmada has 6 key features. Try to solve with these features
It's right
about
now.
to solve what we spoke before about the problems with these 6 key features. First is multi-cluster management. Also, second is workload propagation across clusters. Third is cross-cluster application failover. And also, in many clusters, we have a unified in train to do unified authentication. The next one is global view. So we aggregate all the resources and give a unified in train to view the resources. And also here is many clusters in different clusters, many services in different clusters. So we try to implement a efficient way to do service discovery across clusters. Okay, here is something.
I think it's fine now. You can go ahead.
Is everything okay? I can see there's some.
Yeah, it's okay now. It's okay now.
Okay. So I continue. Okay, the first point is multi-cluster management. So from the picture, you can see the left. Before we have multi-clusters, many clusters. If for one deployment, you should deploy it and upgrade separately. So the operations is repeated and duplicated. It's complex to manage multi-clusters separately. But with Karmada, you see here we can deploy and upgrade in one step. It's quite easy to manage in multiple clusters. So the key benefit is significantly reducing repeated management operations. Here is a feature. So it could be for the clusters, it have 2 resolution model, push and pull. So for the pull model, push model, it involves directly communication between Karmada and mobile clusters for management purpose. With the pull model, so Karmada will delegate management tasks to Karmada agent. Here it's an agent, and the agent will be responsible for management that the service deploy. Okay, the second point is workload propagation across clusters. For the Karmada, it accept Kubernetes native API resource and propagate them to member cluster. With the propagating policy, you can select a target cluster here, like based on the topology, like Zoom, or like a cluster name or class name. It can be specific or topology. Additionally, as a resource manifest may vary different cluster, Karmada provide override policy to implement a differentiated configuration. Like in cluster A, you want image A, but in cluster B, you want image B. So including image and labels, it can be differentiated with the override policy. Then the next point is cross-cluster application failover. Like here, they have two steps. One is we find a faulty cluster post connection. So the second step, we will migrate the workload here from member 1 to member 2 and 3. So this process is gracefully, like it create first, then delete from the older cluster. So it can ensure gracefully migration and ensure uninterrupted services. The next one is unified authentication. Like here also the same as before. Before you need to match them multiple kubeconfig and separately authentication and audit here. But with Karmada, it's just one unified kubeconfig, and it could do unified authentication audit. It had just one train, so it could significantly reducing the effort required for authentication and audit. And next one is our global resource view. Here, Karmada cache all member cluster resource by supporting third-party storage and local storage, like here, ES and DB. And provide a unified in-train. You can query from here. So you can query all member clusters in a unified in-train and efficient manner because it didn't go to member cluster. It search the data from database. So it could greatly reducing the access pressure on member cluster. So with some, like a dashboard, open source dashboard, you can query efficiently and very fast. So the last point is multi-cluster service discovery. So deploying service across multiple clusters and enable them to access each other are very common scenarios. Karmada enable cross-cluster service discovery communication through service import and export after connecting the cluster networks through like Submariner or other ways. So it will automatically sync the service. Then you can call the service sync the service like in single cluster. So this is like effortless. Effortless cross-cluster service communication, like a single cluster. It's very easy. Yeah, that's all. That's a 6 key point about the
Can you hear
to
me?
solve the problem here. To give a general API
there's a latency.
then you can run your application efficiently across the multiple clusters. That's all. Thank you, guys.
Excuse me, can you hear me?
Yes, I can hear you.
Yeah, I have a question for the, can you go back the slides like you mentioned for the cluster communication? So for the cluster mesh, how do you achieve that? By tunneling or by open the ingress? Like for in your, I think in the last page you mentioned the cluster auto discovery. I think it is about cluster mesh, right? How do you achieve that?
John, could you go back to your slides? Hello.
Hello.
Yeah,
I can
can
hear.
you go back to your slides? So actually, the questions about the cluster discovery or service discovery.
Cluster discovery is from your slides. It's more like cluster mesh, right? It's more like a pod running on cluster 1 can talk to pods running on cluster 2. Is that correct?
Yeah.
Yeah, and then how do you achieve that? Like the communication is by tunneling or like by another protocol, like you open ingress.
Well, there's actually kind of multiple layer to work together to kind of achieve this. So for the service name, it's we basically implement the multi-cluster service mechanism. So it's kind of showing in the diagram. Actually, basically we kind of export one of the service from like cluster one, and imported it to the other clusters that basically want to access the service. For the kind of port network or container network layer, you can either rely on the Submariner or something else. Actually, Karmada don't limit the underlying implementation.
Sorry, at this point, I'm a little bit confused. So, so in that service, it's more like that is Kubernetes service, right?
Yeah.
As for example, SVC-full, and then how do, like for each cluster they maintain the information, like when the traffic is out of cluster member B and it is routed to another cluster, like how it know like the real MAC address and so on, all those.
Yeah, so in the multi-cluster service design, basically, once you export and import the service across different cluster, the endpoint of the services will be also loaded to the cluster that has the kind of client or consumer pod. And then it's actually relying on your underlying network implementation. For example, if you use Submariner support the flat network or kind of
Okay.
The other more complicated network. That's kind of one of the option, and you can also rely on something like VPN to deal with that. That's kind of more a commercial solution, and also there are the other solutions like you may also integrate with Cilium. Cilium has the cluster mesh also. I think they also implements that. But for the diagram here in the slide, we are talking about the multi-cluster service mechanism. Yeah, so it's more about the service name layer.
So if I don't know if I understand correctly. So for example, I have a service. So I want to deploy to multiple clusters. And for that service, for that server, not services, for that server, I also have a service or ingress exposed outside. And then how do you achieve the load balancer? It is like our responsibility to implement that logic, or your global, this kind of like global service can also do the load balancer.
So basically, it's the kind of CNI layer need to implement that. For example, Submariner provide the implementation. It will automatically detect if the package is going out of the cluster to another one. So you know that the Submariner is kind of relying on some tunneling implementation. But also actually in the early days in Federation V1, we have one of the implementation. The traffic is going to the load balancer of the target cluster and then reach out to the backend part. Yeah, but we not yet port that implementation to Karmada yet. But I think there should be a lot of implementation at the CNI level to deal with the multi-cluster CNI. Yeah.
Sorry, we are not quite familiar with Submariner, so it's also like a network provider. Is similar like Silico. Is that true? It's handled L2 level to L4, something like that, and also provide CNI. Do you have a link? We can double check.
Yeah, let me send the link. So Submariner is also a CNSF project. And the CNI layer.
Yeah. Thank you. And could you also point me the code for your multi-cluster service, like the cluster mesh code, and then we can take a look.
Yeah, I think you can ping me on Slack, then I will send you the link. Okay. Does anyone have any questions?
Yeah, I have a question. Is regarding the work. If we go back to the earlier slides, there's a mention of the work. So is the work more of a high level concept, or there's actually an API that is called the work? Because when I go into the Karmada repo and I look at the API tree under work, it's I think it's actually called the resource binding. So could you talk a little bit about the work that is described in this diagram? Thank you.
Yeah, do we have the API workflow diagram in this slide? Jiangwei, do you have that?
Here I haven't got here in this PPT.
No workflow in the slides. But I think Jiangwei, could you please send a link to Mike or Mike? I can send you after the meeting.
Okay, thank you.
Yeah, so let me just briefly introduce the mechanism. So it's like bind the propagate it's called the binding. Yeah, the binding basically kind of reflects the resource template or the application. So the work is likely if you can find out which one. Yeah, this is a little bit more clear.
I think here is
yeah, this is the API workflow. Actually, not the workflow. It's the concept layer. We also have another workflow, but this should be fine. So so we kind of treat every the Kubernetes vanilla API object, for example, deployment, as the resource template. And we have the propagation policy to kind of match and kind of filter and match on the resources. You will find that there's the resource selector failed in the propagation policy, right? When the resource template can get matched by the propagation policy, the resource binding will be generated, and the Karmada scheduler will start working on it and find out which set of the clusters, or maybe also which one of the clusters could this bind, or could this part of the application being scheduled, and add the scheduling result back to the binding, and then the Karmada will help generate the work. So work is more likely the resource template kind of rendered dedicated for each cluster. So you have one of the object with customized object dedicated for member cluster 1, and then the other for member cluster 2. So the work will be stored in a special namespace called the execution space. It's kind of dedicated for from the cluster perspective. So we think that more the work API is more likely system layer or internal usage between the Karmada components. That's the basic idea of the Karmada project.
I see. So there is a defined work API, but it's just for internal and not for external use.
Yeah, so we are expecting users to like interact with the resource template propagation policy override policy. Yeah, we are not expecting people to directly edit resource binding or edit work.
Got it. Thank you so much.
Can you talk a little bit about how you handle different authorization mechanisms when talking to different cloud providers? Is that like a drop-in plugin, or is that all configured by the users running Karmada?
Yeah, actually, for the cloud provider, we think it's kind of more like for example, the cluster lifecycle management. You need to talk to the different cloud provider.
Right.
So yeah. Currently, actually, what Karmada do for the cluster lifecycle management is we do a little bit automation after the cluster being created with the cluster API. So today, if you run Karmada together with the cluster API implementation, the cluster created by the cluster API will automatically register to the Karmada control plan. Yeah, so that's kind of automation. Karmada don't wrap cluster API today.
Yeah. Thank you.
So just a little bit expanding on that topic. After a cluster is registered or added to Karmada, how does the Karmada notice changes in the, let's say, the resource or is there some informer or some watches being added as some progress somewhere? Thank you.
You mean the resource change of the cluster, right? The member cluster,
Yes.
right?
Yes.
Yeah. So today, actually, the It actually depends on whether you are kind of managing the cluster with pull mode or push mode. But actually, the underlying implementation is kind of similar. Just where you run the informer, the lister. So in the pull mode, actually, the informer is kind of running in the agent. And the push mode is running in the controller. Yeah, that's the little bit difference. But actually, we have the informer to kind of collect the whole cluster state and also report to the information we need to the Karmada cluster object. So we have a kind of abstraction. Information abstraction of the cluster status, like the capacity and also the resource usage. You can take a look at the Karmada cluster API, and you will find out the idea. Yeah.
Thank you.
Okay, I guess the meeting time has been run out. If you have any questions, please feel free to send an issue or ask in the Slack. Okay. Next time, I think I can share the features of the next release. Now, I guess, see you next time.
Bye.
Yeah. Just to add, if any interesting topic you would like to discuss, please also feel free to add an item in the meeting agenda. Yeah.
Sure. Okay.
All right.
Bye, everyone. Thanks for your time.
Yeah, thank you.
Bye.
Thank you. Bye.
Thank you.
Thank you.
Thank you.
Thank you. Bye.
Bye.
It helps me just